Okay, this is a video working through problems number 8 and 10 from section 11.1 on the homework. These two are pretty similar problems in terms of what they're asking for, but they're each asking it in a little bit different way. So they're asking first to find the measure of arc DE. So we want measure of arc DE and then round that to the nearest hundredth. So the measure of arc DE, round it to the nearest hundredth. That means we're looking for a degree measure. So our answer is going to be something with degrees. The nearest hundredth means we're going to see two decimal places. If I had to guess, I mean, looking at it, it's below 90 degrees. So it's certainly above 0, probably above 10. But let's say it's reasonable answer if we get one's going to be somewhere between 0 and 90 degrees. And I know that seems like a small thing, but when we're actually going through a problem-solving process, it's important to know kind of what we're looking to hit. And I think from the picture, we can at least infer that much. Okay, so let's get started with it and figure out what we can do. First off, I've got a little sliver of the arc, and I'm told that's 8.73 inches. So that's part of the whole thing. And that's what this lesson 11.1 is about. So we're going part over whole. Part over whole. And we've got what part we're after. So we've got this part. And what our equations are is part over whole over part over whole. And one of those part over wholes is going to be distance, and the other is going to be degrees. And this lesson's so tricky because it's asking you to think in percents, and it's asking you to think in fractions, which are what percents are. So you're looking to say what percent of the circle does that 8.73 represent, and then that percentage needs to get applied to the overall total for degrees in the circle. So for degrees, let's fill in that part. The whole for degrees is 360. That's always going to be true in a circle. That's the whole. The part, I don't know. That's actually what I'm after. So the part, I'm just going to call it x. So that's what I'm calling this in this problem, the way I'm setting it up. I want to know what x is. And if I'm looking on this side, if I put it right here, that's what I'm looking to find. So I've got my equation set up on the right-hand side. On the left-hand side, I know the part for distance is 8.73. I do not know the whole. So I've got 3 of the 4 pieces. To solve this inequality, I need to be able to get something in the denominator on this left-hand side for distance. So I'm going to go and do that. And the way I'm going to do it is I'm going to use this 10. That 10 is the radius. The whole is the circumference of the circle. Circumference is 2 pi times the radius. So 2 pi times 10. Or we could do 2 times 10, which is 20, and we get 20 pi. And eventually we're going to need to get a decimal for that. We can certainly go and do that right now, or we can just leave it as 20 pi for the time being. I'm just going to leave it as 20 pi. So it'd be 20 times 3.14, and you let the calculator do the decimals. So here is the fraction that I need to set up. It's actually a ratio of 2 fractions. And that's what makes this lesson so tricky. Every single one of these is the same. It's just continually setting up fractions dealing with percents. To get x all by itself, I'm going to multiply both sides by 360. So I'll switch colors here to indicate that now I'm going to actually be doing something to the equation. So I'm going to multiply both sides by 360. And the reason you do that is on the right-hand side, what happens is you cancel numerator, denominator, and you're left with just x. And then this is the big thing you're going to chunk into a calculator. You're going to do 360 times 8.73 divided by 20 pi, and that's it. There are no more steps to the problem. So when you type that in, whatever you get is going to be the answer. So 360 times 8.73 divided by 20 pi. I'll see if I can remember that. 360 times 8.73 divided by, now here I'm going to be careful. I'm going to use parentheses. I'm going to go 20 pi. Just so I make sure I'm dividing by the whole thing, 20 pi. And then I'm going to hit enter. And my answer is 50.0192, and I think they said 2 decimal places, so it'd be 50.02. So then I'm going to go back here, and I'm going to say 50.02, and again, that's in degrees. And thinking through, is that reasonable? Well, yeah, I mean, it fits our rough mold, right? 0 to 90, and that ends up being the answer. So it is the correct answer, but it also fits kind of where we thought things should be. So that's it. That's how you solve this problem. Question 10 is really similar to it. So I'll scroll down here. I have question 10 right down here. They're just asking it in a slightly different way. So I'm going to switch back to the black pen, and then I'll go to the red when I start doing the problem. So find the radius of R. So we're looking to find the radius of circle R. So, and just because R already gets used, I know we use R for radius a lot, I'm going to call that X. I'm just used to using X's, oops, as you guys are as well. So I'm going to call the radius X. Let's see, shift up a little bit there to see the X. And we're going to round our answer to the nearest hundredth. So what we've got here is we've got this big angle is 260. They didn't tell us what this little angle is, but that shouldn't be a big jump to say that's 100 degrees. Together, the two of them need to give you 360. What's a little less certain here on this diagram, and this is where the book I think isn't doing a great job, the 38.95. It's a little, I think we're going to have to assume that it's talking about this stretch right here. From L to M, that major arc. I'm not sure how else to interpret that because it shows up on the left side. They gave us that 260, which is the degree that goes with it. So I'm just not sure how else to interpret that. So I'm going to go with that being the case. So let's see. My part, my 260. There's my part over my whole. So degrees over degrees, just like the other problem. Except on this one, I actually know the degrees. And then the part that matches with the 260 is the 38.95 over the whole. I don't have that. And I'm talking about distance on this left-hand side. That's the whole part of this, or the whole circle. So that means the circumference. So I need to get the circumference of this circle. So circumference of a circle. Well, what's circumference of a circle? Circumference of a circle is 2 pi r. Well, I don't know radius, right? That's what I'm actually trying to find. I called it x, so I guess I could do 2 pi x because I called the radius x. I don't have anything else. I don't know what the radius is, but I do know what 2 times pi is. That's 6.28 roughly. You can type it in a calculator to get way more than that. I'm just going to leave it right now as 2 pi, and I'm going to rewrite this entire expression. And this is tricky. They are asking you not to actually figure out what the radius is. They're actually asking us to just put 2 pi r or 2 pi x in for the whole circumference. And then what we're looking to do is get x all by itself. So once you got the setup, then okay, can you deal with the fractions? There's lots of different ways to do fractions. When I see a expression like this one where I've got something in the denominator that has a variable, I'm going to cross multiply. So I'm going to do 38.95 times 360 equals 2 pi x times 260. And I think a lot of the reason this homework gives people challenges is because you are dealing with fractions. And I think the bigger challenge is not the geometry content, but it's having to fight through how do I deal with these fractions, what goes where, how do I solve for it. Those are all algebra questions, and they're good ones, but they are algebra questions. So let's see. I've got 38.95 times 360. Let's just go and do that. So 38.95 times 360, and that's going to be 14022. Oops, 14022. And then I've got 2 pi x 2 times 260. So 14022, I'm going to do this in two pieces. So I'm going to first divide both sides by 260. I could do this in one, but there's no rush, so let's just do it in two. Divide by 260, hit enter. That's going to be 53.93. And I'm just going to leave that in the calculator. Equals 2 pi x, and now I'm going to divide both sides by 2 pi. And again, what I'm going to do is just leave that number in the calculator. I'm going to hit divide by, I'll use my parentheses, 2 pi. And then I don't have to type in all those decimals, and I hit enter, and there's my answer, 8.58. And that is the answer. So 8.58 is my radius, and I could have called it little r. I chose to call it x. But that's it. And in truth, once you're done with the setup, so once you've got it to here, the geometry's over. And that is challenging even to get it to there. But I think for most students, the challenge is now, once I've got it there, can I dig this thing out? And again, I want to stress this equation from number 8. So right here, part over whole and part over whole, distance and degree. That's it. There's no other idea in this section or in this part of chapter 11. So that should be the focus with each of these problems and figuring out how to use that ratio comparison.